All right, here's a quick video for the Pfrqs. Okay, first of all, when the two function names are written right next to each other, it means multiplication. So we're going to take the derivative of this using the product rule. And don't forget to do that. You have to take the derivative of each one. It's like they're taking turns. And so I inserted the functions right here, and then I'm doing the product rule. So the first thing I do is I take the derivative of the first guy and multiply it times the second, and then I multiply the derivative of the second one times the first. And a little bit of simplifying just to make it look pretty. This is what we would get. Okay, next, we're going to first fix this. Those should be h's. And then we're going to do a derivative of a composition of functions. Whenever you do that, you're using the chain rule. So let's get it. Okay, so first we're told that we need to, what h of g of x is. And so we write that out first, and that's one of our answers because it says define that. Next, we're going to take the derivative of this, and so I'm going to write it out like this and put a little prime there next to it. You take the derivative of the outside function with the inside function inside of it, and then multiply it by the derivative of the inside function, and then you're done. Now this looks kind of sloppy, so I'm going to clean it up just a little bit. That goes up on the numerator, the 2 times the x minus 1, and then the denominator is the 1 plus x minus 1 to the 4th power. Next, we're going to do the inverse. Okay, now this is weird because we had to define the j as g, but with a certain domain. It doesn't really change the j that much. That's just because the g function wouldn't have an inverse because it doesn't pass the horizontal line test. So we write out the derivative of the inverse formula, because whenever I see the word inverse in my problem, I'm going to write the formula because it gives me a roadmap as to what I'm going to do. So the first thing I need to do is find out what k of 1 is. And so to do that, I'm going to write my tables just to give us a visual. We're plugging x into k, which means j equals 1 for our other function. And so we set 1 equal to j by subbing. Actually, we don't set it equal. We take the j out, and we put the 1 in. And then we solve. Okay, when we solve it, we get a plus or minus 1, and then we get a 1 plus 1, and then a 1 minus 1, which gives us two answers, a 2 and a 0, but we know that the 0 doesn't fit in our domain, and so it's not one of our solutions, and so it has to be 2. And so we have a 2 for the k when x equals 1. And so we plug in the 2, and now we just need a j prime. And so we're going to get j over here, and we're going to find the derivative of that, and then we're going to take that j prime and plug in the 2, and then we get another 2. And so that's going to be plugged in at the bottom of that fraction to give us our answer for the k, or the derivative of k at 1. Okay, next, we got to find the tangent line for k. So I'm going to write this out just to give myself another roadmap. What do I need to find in order to find this tangent line? And I have to find k of 1. I have to find the y. And then I have to find k prime of 1, which is the slope. And so I look above, and it looks like we already found what k of 1 is, which is 2. And we also already found what k prime of 1 is, which is 1/2. And so we just plug those guys in, we get our answer. I'm not going to simplify that because it looks pretty clean, but if you did, you would probably get answers like these. All right, next. For this one, we got to do implicit differentiation. And so for the first one, I'm going to write it out cleanly. I'm going to take the derivative with respect to x of this equation. And then, let's see. I had to do the product rule right here. And so I got some work going on. Now, I did put parentheses around my product rule, and that's because sometimes it says minus right in front of the product rule, and we want to make sure that we distribute the negative. Okay, and then we take the derivative of the y squared, so we get 2y, and then we have our dy dx. Whenever you take the derivative with respect to a different variable, you need to write dy dx, or I could have written y prime instead, and then that equals 0, because the derivative of any constant is a 0. All right, moving on. Okay, so then we have, I just cleaned it up a little bit, got rid of my parentheses. I see I have 2 terms that have a dy dx, and I have 2 terms that do not. So I'm going to move the ones that do not have a dy dx to the other side, and at the same time factor out the dy dx of the other terms that do have a dy dx. And then I can divide both sides by x plus 2y, and then I get my dy dx alone. Notice I factored out the negative at the top. That's just It looks cleaner. If you left the negative in, it's fine. All right. Next, we got to find where the curve has a horizontal tangent line. That means dy dx equals 0. And so I'm going to plug 0 into dy dx. I'm going to sub it in, and then I'm going to solve. The first thing I would do is I multiply both sides by a -1 and an x plus 2y. It's kind of cool because on the left side, the denominator cancels out. On the right side, anything times 0 is 0, and so I'm left with this. And then if I manipulate a little bit, I have y equals -2x. Now, I have two variables, but what I'm trying to find is x, because the question says where. Where can we find all the points? So we just need to know our x value. So what I'm going to do is I'm going to use this equation that was given to us at the beginning, because those are the same x's and y's as what we have down here with y equals -2x. And then I'm going to take out the y's and plug in my -2x, kind of like a system of equations. And then I'm going to solve. So I plug in my -2x, and then I simplify a little bit and get solving. Okay, and then I get x equals plus or minus the square root of 4 over 5, which means that we have a positive square root of 4 over 5, and we have a negative square root of 4 over 5. Now, you didn't have to split them up like that. I just like doing that to help make sure students know what plus or minus means. You could have left your answer like this. Finally, last derivative. So we got the second derivative, and so what we're going to do is we're going to take the derivative of dy dx. And so when we do that, on the left side, we got the second derivative, and then on the right side, we're going to have to do the quotient rule. So we take the derivative of the numerator first, multiply it times the denominator, then we subtract. Now we have to take the derivative of the denominator and multiply that times the numerator. Don't forget, every time you take the derivative of y, because we're taking the derivative with respect to x, you have to write dy dx, and then our denominator is squared. All right, this answer is awesome. I'm going to simplify it just a little bit more. Actually, this is not simplifying, I guess. We're writing the second derivative in terms of x and y. And so we have to get rid of the dy dx, which is really easy. We just have to sub out the dy dx, and then we're done. Okay, now for the sake of my problem, for this test, you guys do not need to simplify this anymore. I'm going to be satisfied with this. There's more ways to simplify this, like getting rid of those fractions up top, but we're not going to need to do that for my test. So on to the next one. Okay, for the first question, it says use the Pythagorean theorem to find the missing side. I'm going to label my missing side A. So I'm going to set up my Pythagorean theorem and get the A alone. And after I get the A alone, I see I got plus or minus. But guys, this is geometry. You don't have a negative side. That doesn't make sense unless you're in a Cartesian plane, and we're not. So we only have a positive square root of 1 minus x squared. And then the next question says use the triangle to find f theta in terms of x. And so I have f theta, and that's sine of theta. I plug theta in the sine, and that's opposite over hypotenuse. And so this equals x over 1. So f of theta equals x. Next, we're asked to find the inverse, f inverse, which you guys know is sine inverse. And we're plugging x into it, and we have to find it. Well, this is actually a lot easier than some of you guys are thinking. All you got to do is switch the x and the theta. When you look at the one that we just found, when we plug theta into f, we get x, and when we plug x into f inverse, we get theta. I could make the two tables, but I don't think it's necessary. I think you guys see that the x's and the y's switched. Next, we have g of theta. So what happens when we plug theta in the cosine? Well, we get adjacent over a hypotenuse, so it would be the a over 1, and we know what a equals. A equals the square root of 1 minus x squared. And so g of theta equals the square root of 1 minus x squared. And finally, we get our inverse. Oh yeah, don't forget to box your answers. This is supposed to be an x right there. It makes more sense. It doesn't actually work if there was a theta there. So we write out our inverse function, our inverse formula, and it provides our roadmap. First thing we need is f inverse of x, which we got. It's above. Check it out. It's right here. That's theta. And so now we have to find 1 over f prime of theta. What is f prime? Let's see. F prime would be the derivative of sine, which gives us cosine. And so if we plug theta into that, hey, that looks like the other problem that we had on letter D. And so that gives us our answer, 1 over the square root of 1 minus x squared. And holy snap, check that out. That is our formula. the derivative of sine inverse. That's pretty cool. That's rad.